Hi Physics 20. I'm here to do an example of a box on an incline. Okay, this is similar to a lot of questions we're going to do. Check it out. So we got a 5 kilogram box here. We know it's accelerating down the ramp 1.5 meters per second squared. We're going to find the force of friction. Okay, as always, we need to identify all the forces acting on this. So, since I'm on video, I'm using a ruler. That's rare. Here's the gravitational force, always straight down. Okay, then there's going to be a perpendicular force. I'm breaking the gravitational force into its components here. So there's perpendicular. Here comes the parallel. Okay, I'll make sure they meet. I'm trying to make this look nice. All right, so here's perpendicular component of gravitational force. Parallel, this angle is also 30 degrees. Okay, we get a normal force in line with the perpendicular force. I don't think we're going to need it, but we're going to label it. As this thing goes down the ramp, we know there is friction resisting that, so it's going to be directed up the ramp. So the free body diagram shows us all the forces and is how we're going to be able to solve this question. And we use the free body diagram to figure out how all the forces relate to each other. Okay? So I want to identify here the direction of the net force. The net force is down the ramp. And we know how to calculate net force. Mass times acceleration. Okay? You don't need to calculate it right away. You can do things algebraically, which is sometimes advantageous. But I'm just going to do it like this right now, because quickly I see we got 7.5 newtons pulling this box down. Okay, so the direction's down the ramp. That's just there to help me organize my thoughts here. So the box, 7.5 newtons down the ramp. Okay? What's most important, and what I'm stressing in class, is how to relate the forces from your free body diagram, usually into a net force. Okay? The net force, as we know, is down the ramp. So it's going to equal whatever forces are down the ramp, subtract the forces up the ramp. Okay? There's only one force here down the ramp, and it's this parallel force. Okay? It's the part of gravity directed down the ramp. Resisting that is friction. It's up the ramp. The perpendicular force and the normal force just cancel each other out. Perpendicular is into the ramp, and the normal just makes that equal to 0, because we know this box isn't accelerating in either of those directions. Later, when we learn more about friction, we'll be much more interested in these. But for now, just notice that they cancel each other out. Okay, so we know what the net force is at 7.5. We don't know this yet, but we certainly can get it. As always, the parallel force is the gravitational force times sine of the angle. Okay, gravitational force is mg. Okay, so this is going to be 5 times 9.81 times sine 30. Okay. That's giving me 24.5 newtons. Okay, that's the total force pulling it down. The net force is only 7.5 because friction is taking some of that away. So if I'm going to write this out, I might recommend doing it algebraically first, but let me just do it this way. It's 7.5 is an equal to 24.5 minus friction. Okay, if you shuffle this around, friction is just going to be these guys subtracted. Okay. So let me check all the decimals here off screen. Yeah, we'll just call it 17 newtons is friction. Okay, it's directed up the ramp. I don't need to see that though because it's in your free body diagram. Okay, so I hope this helps. This is kind of a general box on incline question. The free body diagram is hugely important. It organizes your thoughts. It's where all this stuff comes from. I don't want you memorizing steps because every question's a little bit different. Okay, I hope this makes sense and good luck.